everyone. I am KRANTHI KUMAR, Assistant Professor in the Department of EC, Marri Laxman Reddy Institute of Technology and Management. So today here we are going to discuss the basic things in microprocessors and microcontrollers, like the architecture, the registers, the definition of microprocessor and microcontrollers. So the basic things we are going to learn in this video lecture. So the main outline of this course is the course objectives, the introduction, the features of 8086, architecture of 8086, and the final, the register organization of 8086. So the course objective of this course is understand the architecture of microprocessor, gaining some knowledge about programming of microprocessors, study the architecture of microcontrollers and programming for various applications. So learn about the interface devices and interfacing techniques. The final one is understand the basic concept of architecture. So what is microprocessor? Microprocessor is nothing but central processing unit built on a single integrated chip is called a microprocessor. Simply your microprocessor nothing but is your CPU. So what do you mean by microcomputer? Say a digital computer with one microprocessor which acts as CPU is called as microcomputer. The microprocessor contains millions of small tiny components, transistors, resistors, diodes. So all these are work together to execute an instruction or perform any task. So what do you mean by microprocessor? The microprocessor nothing but it's a computer's central processing unit, so built on a single integrated chip. So this is the black diagram of general microprocessor. So here, so your microprocessor nothing but your CPU. So this is the CPU. Generally the CPU consists of ALU and array of registers and control unit. So the input device, generally we will use keyboard and mouse are the input devices. So output device like your screen or monitor, printer. So these are the output devices. So memory, we have main memory and secondary memory. So your microprocessor simply is it's a CPU. It consists of an ALU and control unit and a registers of array. So the input device, what are the input device here and the output device and memory. So everything we have to externally add to the CPU. We have to interface the CPU. So it is the main difference between a microprocessor and microcontroller. So if you want interface and keyboard to the microprocessor, so we have externally connect a keyboard or mouse to the processor. So like that, so the output device will be interfaced to the processor and the memory will also interface to the processor. So your microprocessor is nothing but a CPU. So these are the general features of 8086 microprocessor. So it consists of an 6 byte of instruction queue, so which will increase the execution speed. It was the first 8-bit microprocessor having 16-bit ALU, 16-bit registers, internal data bus and 16-bit external data bus, and it is available in 3 versions like 5 MHz, 8 MHz and 10 MHz, and it supports the 2-stage pipelining, the fetch and execute stage only. Okay, so fetch stage can prefetch of 6 byte of instructions and stores them in a queue. So execute state and executes these instructions. It has 256 vectored interrupts and it consists of almost 29,000 of transistors. So all these are transistors work together to execute or perform an instruction. These are the general features of 8086. So 8086 is a 16-bit microprocessor. So your data bus and your address bus and your registers all are 16-bit, which means it will handle only 16-bit data. It will process only 16-bit of information. So it is the architecture of 8086. So the architecture of 8086 is divided into two parts. So one is bus interface unit, BIU means bus interface unit, and the second one is execution unit. Okay, so the bus interface unit, so first we will go through the bus interface unit. So the bus interface unit consists of some registers, segment registers, so and instruction pointer along with 6 byte free fetch queue. Okay, so the 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 bus interface unit consists of segment registers. So code segment, CS means code segment, SS means stock segment, DS means data segments, ES means extra segments, IP means instruction pointer. So along with the segment registers, it also consists an adder or summer. This is the adder or summer. So the main purpose of the bus interface unit is to fetch the instruction from the memory. For that one, so the bus interface unit will generate an physical address. So what is the physical address? The processor generate address is physical address. So to access the memory, here the memory is connected outside the microprocessor. It's not a part of the your microprocessor. So externally we have to interface or connect the memory to the microprocessor, right? So it is an instruction queue, so 6 byte of instruction queue. So this will increase the execution speed. So for example, here I have a memory location. This is the memory. So in particular memory I have my instruction something, so 10010. Okay, so this memory is interfaced to the microprocessor, right? So the instructions, the bus interface unit will fetch the instruction from the memory, by generating an physical address. So what is the physical address? The physical address equal to segment address into 10 less offset address. Okay, so physical address means okay, so here the physical address is segment address into 10 plus offset address. So using this physical address, so the bus interface unit will fetch the instructions from the memory, So if the instruction is fetched from the memory, it will be placed in the instruction queue, so based on the locations 1st to 2nd, 3rd, 4th, 5th, 6th, like that. Okay, so suppose I am the first instruction will be stored in the location 1, the second instruction will be stored in the location 2, right? So after executing the first instruction in the instruction queue, okay, so the second instruction will be executed, right? So coming to the execution unit, so the execution unit consists of general purpose registers like AX, BX, CX and DX. These are called the general purpose registers, and some pointer registers, stock pointer, base pointer and index registers. Okay, so source index and destinations index, and it is also consists of some control unit and ALU. So after receiving the instruction or data from the memory, so the bus interface unit, so it will be stored in the instruction queue. From the instruction queue, so the control unit, the execution unit will be receive the instruction. Okay, so now the control unit will activate the ALU. So the your control unit activate the ALU and general purpose registers. So the general purpose registers mainly are used for to store the information temporarily, So the source SP source pointer, stock pointer, base pointer, source index and destination index. So these are called as offset registers. So all these registers are 16-bit. These are called as offset registers. So all are 16-bit registers. So your general purpose registers AX, BX, CX and DX, these are also called as 16-bit registers. So if H means, so AH plus AL equal to AX, which means H is 8-bit and AL is 8-bit, which means your microprocessor can work for 8-bit data also. Okay, so higher 8 bits and lower 8 bits. The combination of higher and lower 8 bits is your AX register. This is the 16-bit general purpose register, right? So what is mean by offset address? So consider this is an book or memory. So consider this is a memory, so or a book. So your book is, your textbook is nothing but a memory. Okay, so I'm considering your textbook is nothing but a memory. So I'm saying that page number 6, right? So here the page number 6 is the physical address, right? So the page number 6 is the segment address. Okay, segment address. So what is the physical address formula? Physical address is equal to segment address into 10 plus offset address, right? So here the segment address is your 6. So I have a memory or book. So in that book, so my required data is available in page number 6. That is your segment address. So in page number 6, so in which line so your required data available? It is maybe line 1, line 2, line 3, line 4 or line 5. So there are several lines in the page number 6. So in line 3, so my data is available. So this is nothing but your offset address. This is nothing but your offset address, which means so the exact location of the data will provided by these offset registers. The exact location of the data, so in the segment register, will provide by the offset registers. So this is the bus interface unit and execution unit. So the execution unit gives the instruction to the bus interface unit. So starting from where to fetch the data and then decode the and execute the instructions, which means so it is providing offset address to the bus interface unit. So how to fetch the data, where to fetch the data, this information is provided by the execution unit. Next, coming to the register organization of 8086. So there are several registers in the 8086. All are 16-bit. Here AX and BX, AX, BX, CX and DX. These registers are called general purpose registers. So your AX register is holds the results during multiplication and division operations, right? So your BX register holds the offset address in indirect addressing mode, right? So your CX register holds count for instructions, right? Your DX register is used for, so it is an extension version of your AX registers. So in during multiplication operation, if you multiplying two 16-bit numbers, so 16-bit, if you are multiplying two 16 numbers, the result may be 32-bit. Okay, so the first 32-bit will be stored in the AX register. Okay, the next 13-bit will be stored in the DX register. So your DX register is nothing but it's a default register, and it is an extensions to AX register. Next, pointer and index registers. The stock pointer, base pointer, these two registers are called index registers, pointer registers, and the source index and destination index are called as index registers, right? So the stock pointer points to the top of the stock, right? The top of the stock used during instruction like push, pop, call, return instruction. So all these instructions you will know in the instruction set of 8086, right? So your base pointer can hold the offset address of any location in the segment, right? Your source index holds the offset address in the data segment during string operations only, So destination index, it holds offset address in extra segment during string operations. Next, coming to the segment registers. Okay, so we already discussed, so code segment, data segment, stock segment and extra segment, these are called segment registers, right? So CS stands for code segment. So it is used for addressing a memory location. It is used for addressing a memory location in the code segment of the memory, right? So your DS stands for data segment, right? So it consists of data used by the program and accessed in the data segment by an offset address. Okay, by an offset address. Next, coming to the stock segment. So it handles memory to store data and addressing during execution, right? It handles memory to store data, so and address so during the execution, right? So next, coming to the extra segment, it is an additional data segment. It is an additional data segment. So the last one is instruction pointer. It is an 16-bit register used to hold the address of the next instruction to be executed. Address of the next instruction to be executed. For example, I am going back. So here I have 2 or 3 instructions. The first instruction will be stored in the position 1, and the second instruction will be stored in the position 2, and the third instruction will be stored in the position 3. So here the first instruction is executed, and the second instruction going to be executed. So the address of this second instruction will be stored in the instruction pointer. Okay, it will stores the address of the next instruction to be executed. Okay,